number.
How do I submit it?
How?
Do you just, I don't know, wait.
I got.
Go, that's so scared. How do I move to the next one?
Type it in, just
Hover
the way you
over
have.
it and
Oh,
press
yes.
enter.
I'm sure.
I
How do we submit?
want to change my answer on one of them.
You want to change your answer? You
Yeah,
can't change your
How
answer
do I
anymore.
submit?
I just picked.
Document, which is the button under on, and then submit, which is number 1.
Wait, my agree.
Doc
Wait, is it?
and enter.
Okay, so I did wrong.
Kidding, it's positive.
Good?
Really?
Alright, did we get everybody? Do I have 2 people? 2 people, 1 person?
Wait, how do you submit?
Hurry up.
Oh.
Alright, so let's see what happened here. This is kind of a way of integrating technology into our classroom and using the Inspire and the Navigator together. I think it's pretty cool.
I was gonna put one for you, but
Right? So let's look at our results here. Right here, got my wires.
That's so cool.
I get what I did.
What did you put?
I almost put negative 3.2.
Alright, so this is the first question. So 17 of you got the right answer.
why is your grade
You
one?
put
number
13.
one?
Oh wait, that's not the first question. This is the first question. 16 of you got the right answer, negative 2.2. Okay, some of you put 1.8, some of you put negative 1.8, some of you put 9.2. Okay, so that tells me something's going on there, right? Maybe Mr. Science needs to talk to this person and see what's
That's not me. That's not me.
Four pieces.
That's not me. I got it.
Actually, 3, 4, 5, 6
I got
people
both
got
of
it
them
right.
right.
Automatically, I can get that information without having to go to every single one of you, right? That's pretty cool.
That's cool.
Now if I come to this one, 17 of you put the right answer, right?
Mine was a mistake.
Okay, some of you put 13, 2 of you put 13, so we need
Okay.
to talk about that. Why did you get 13?
Because I forgot to put the negative, but I knew the negative.
So you plugged in 3.9, not negative 3.9, okay.
Sorry.
It happens. Okay, here we got negative 2.2, negative 5.8, negative 9.6. So we need to figure out what's going on there, but it looks like the majority of you
I
understood
think
it.
the negative 2.2 got confused.
They got confused?
Or maybe.
Maybe they rounded, right?
Yeah, they rounded.
Or maybe they put the answers in the wrong places or something.
Or maybe they just thought it was the same thing.
No, they just rounded.
So maybe this one's technically correct. Let's see who put that one.
We put that.
Christian.
You can see.
I can see, right? So I
Hover
can
over that too.
Wait, why is your
Come up
blue and
here.
gray
Hover over the
one?
13.4.
keep losing signal.
Oh no.
I'm probably like running out of battery on my thing.
Just like with.
Hover over it.
So if I hover over this, it tells me all the people.
I'm actually there.
Hover over the foot. Oh
This one?
no. Yeah.
He said that, yeah. Okay, excellent work. Good job, all right? So, now let's work it out and let's see how we are supposed to get the correct answers. Okay, now this should be done without a calculator. So the first one, we have to use this equation. So y plus 2 equals negative 2 times negative 3.9 plus 4. When I add those two, what do I end up with? 0.1, 0.1 times 2? Negative 0.2, right? Minus the 2, so that gives us negative 2.2. Good? Then we do the other one. That one's being plugged into the original function. And we're plugging in negative 3.9. So we get 1/2 times negative 3.9 plus 2 squared minus 4. Now let's see if we can get through this one without a calculator. You could plug it into that one also, the simplified or the expanded form. That also works, but I think this one's easier to work if you don't have a calculator. So negative 3.9 plus 2. What does that give us?
1.9.
Negative 1.9, right? If I square negative 1.9, that's like saying negative 1.9 times negative 1.9, right? But I think of it as being 19 times 19.
Yeah.
And we should know our perfect squares up to 30. So what's 19 times 19? 361. Very good. Okay? So remember learning your perfect squares in algebra 2? At least up to 20.
Because there's a 16.
How about 25 squared?
To 12.
625. Okay. How about 11 squared?
121.
121. 12 squared.
144.
Don't you remember we had that quiz, or I told you we were going to have a quiz, and you went home and you studied and you were going crazy? And then I didn't even give you a quiz? Anyways. Alright, so this is 361, but how many numbers would be after the decimals?
2.
2, so this is actually 1/2 times 3.61. So what's half of $3.61? What's half of $3? 150. What's half of 60 cents? 30, right? So 1.5 plus 0.3 1.8, right? And what's half of 1? 0.5. So what would we end up with there? 1.805. Was that easier than you thought? Yes? Okay. And now that, minus what? Minus 4. What's $4 minus $1 and almost 80 cents? 4 take away 1 is what? 3, right? So almost $2? Almost isn't enough.
It's 2.195. That's the report.
2.1.
How much?
2.195.
Negative 2.195. Okay. So those should have been the correct answers, right? What do you notice about them? They're very what? Very close to each other. Okay, why are they very close to each other?
Because it's a tangent line.
Because the tangent line and the curve are really what? Close to each other. But are they equal to each other?
No.
No, where is the only place that they are equal to each other?
Point of tangent.
Point of tangency, which is at what? Negative 4, right? Okay? But I could use the tangent line to make some approximations about the original function, which is what we did. We approximated the value on the original function using the what?
Tangent line.
Using the tangent line, right? So if we were to use our calculator and zoom in really close to in this area, we would see that they're not really touching there, right? Okay? The point on the tangent line would be very, very, very minimally below the blue point, which I'm going to consider to be the point on the what?
Graph.
On the curve, right? On the parabola. Do you understand? So is this an over approximation or an under approximation?
Under.
Under? Why is it under?
Because negative 2.2.
Because it's smaller than this one, right? Okay? How could I tell if it's an over and under, but just by looking at the graph? How could I know that points on the tangent line are going to be under approximation in reference to the original graph?
If the curve is curving away
It's
from
below
the tangent
line
line.
below the curve.
Because the tangent line is below the curve. Didn't I ask you that question earlier? Yeah? I asked it on purpose, okay? Okay, so the tangent line is below the curve, therefore all the points on that tangent line will always be less than the points on the actual curve. So it's an under approximation, okay? Why is this an under approximation again?
Tangent line's under the curve.
Because the tangent line is where?
Under the curve.
Under the curve, okay? What do you think, what would I have to do to get the tangent line to be on top of the curve? How would the graph have to look? No, if it's increasing, it's still gonna be underneath it. How would the curve, how would I have to change that graph so my tangent line would be on top of it?
It would have to be approach.
Flip it, so what would that mean? Reflected, right? So now if I had a parabola that was opening down, my tangent line would be what? On top of it, right? Okay, now would that be an over approximation or an under approximation? If I use points on the tangent line.
Over.
Now it would be an over approximation, right? Because my tan line would be where? Above the curve, okay? Anybody know what this is called when a parabola opens up? Starts with a C and ends with ave.
Concave.
Concave, okay, concavity is talking about how the function is. Okay, but concave by itself doesn't answer the question. This is concave what? Concave up, very good. Okay? So this parabola is concaved up, right? Like a cup. Okay? If cups were not concave up, they would not hold liquid. Right? Okay? Now, what if it were the other one that was reflecting down? That would be concave what? Down, like a frown. Very good. Like a mustache? No. When I had it all the way down, it was cool because I could use it as concave down. Or concave up, but I shaved it off. I'm gonna let it grow.
Yes, grow
You're gonna hold
Like a beard, like all the way.
Yeah, no brain.
No shave November.
Good. Okay, so you need to know that because on the test there's going to be a question that is going to say that the function is concave up. You need to know what it means when I write that, okay? So that's an easy way of knowing whether the tangent line is above or below the curve. If the function is concave up, the tangent line will always be under it, right? If the function is concave down, then the tangent line will be above it. Okay? And there's tests that we can do to figure out the concavity of the graph without knowing what the graph looks like. Okay? And that's called the second derivative test. We get the derivative of the derivative. Órale. Okay? And then we do a test on that guy, and then we'll be able to know if it's concave up or concave down. And then we put all the stuff together, and we know all these wonderful things about the original function. And then we relate it to the real world. We start talking about velocity and acceleration. Wow. The beauty. Your brain hurts already? Alright, so let's answer the last question. What do you notice about the values of these two results from question 3? What do we notice about them?
Very close to each other.
They're very close to each other, so let's write down. The two values are very close to each other. Okay. What does this imply about how the equation of the tangent line might be used? So what do you think this will help us with, or what would be the good thing about having a tangent line and how can we use it? Very good. So the equation of the tan line can be used for what?
To approximate.
To approximate, beautiful, I like that word. To approximate what? The y values of the y values of nearby, okay, x's for, there we go, the original function. Okay, if you get too far away, it's still an approximation, but it won't be as what? As accurate, right? For example, if I wanted it at -2, would I use the tangent